Hello everyone, welcome to the 11th tutorial session of Probability Foundation for Electrical Engineers. Actually, this is a revision session for the different topics we have actually covered in the previous classes. So this is just to give a glimpse that what we have covered till now and how the questions are being framed, and which will help you to for your examination of this course, and also to strengthen your concepts and on the basics and all. Okay, let's move forward. Try to solve this first problem. This is related to the CDF problem, that distribution functions, and here you have to find out what is CDF at the point 0.5 equal to. Okay, try to solve, and I will give the solution after a few minutes. And if you face any doubt and want some concept, just let me know in between as well. Okay, let me give the solution for this. So it is in the question. It is being said that key if x is continuously strictly increasing CDF, then y is equal to fx of x and has a CDF at point 0.5 equal to. Okay. So when you see that key x is a continuous random variable, which is strictly having CDF fx of x. So here the y is being defined as like this, because it's a CDF is like this. Okay. So, and by the probability integral transform, that y is a uniform variation is 0 to 1. So the CDF will be simply equal to, if y is less than or equal to y, so it will be equal to y, and y is between 0 to 1 because it's a uniform distribution between 0 to 5. So when you plot it also, it is will simply 0 to 1, and here it is like this, and 1. Okay, so when you plot it like this, so it will be simply at y is equal to zero point 0.5. So suppose I'm taking here, so what is the value here, like this, y, because it's a simply y. Okay, so at y is equal to zero point 0.5, so it will be simply at zero point 0.5 only. Okay, because the area will say it is at zero point 0.5. Okay, so let me figure it out here. Okay, suppose at zero point 0.5 we want. Okay, so CDF, when you find it out, was simply the area, which is equal to 1 multiplied by zero point 0.5, simply zero point 0.5. Okay, this is the actually the answer. Okay, 0 is not the answer because that is simply less than zero point 0.5, it is 0, which is not true. And this confuses the PDF, and the zero point 0.5 is also not correct. 1 is also because it is asking of the less than zero point 0.5. Okay, let's move forward, try to solve this problem. Here it is saying that probability that all the tosses are head in the infinite tosses with the probability of head is being zero point 0.5. Try to solve this problem. And if you face any doubt, just let me know. Okay, let me give the solution. So here what is saying that ki probability that when the all tosses are head in the infinite tosses, it is asking what is the probability of head if with the probability of head being the point 0.5. That is simply that ki all overall probability will be 1. So here the of the probability of head is being point 0.5. So similarly the point of probability of tail will be the point 0.5. Okay. So when you say that ki all the tosses will be hit, so it will be simply like this: ki you are tossing first head, second head, third head, dot dot dot, and then toss. Okay, and could be infinity. Okay, so when you say n is going to be infinity, so here if it is a first is point 0.5, second is also point 0.5. When you multiply it, it become 0.25. Okay, again you got the point 0.5, just multiplied with point 0.5, you will get 0.125. So it kept on decreasing. Okay, so initially it was point 0.5, then it dropped down to 0.25, the probability, because it's less than 1, and then it got 0.125, and then further it will lower down the value. So when you take it to the infinity, it will go on decreasing until to 0, not completely to 0, but nearly equal to 0. Okay, so that's why the correct option will be 0. Not saying that because you are having the first head, suppose the one probability it is point 0.5, you get the double head, that same with the probability point 0.5, it become 0.25. So, again you get the point 0.5, and then it become the 0.125, then dot 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 till infinity you take it, go on decreasing, and it become probability nearly equal to 0. Okay, let's move forward, try to solve this problem. Here x and y will be the independent function, and with a uniform probability uniform function that is in between 0 to 1, simply like this. X is also, the value will be in between 0, it will be simply 1, and it values will be lying in between the 0 to 1. Okay, these are the values basically. This is x. Okay, try to solve this problem. Okay, let me give the solution for this. So what it is saying that x and y will be the independent u0 to 1. It is asking the probability of x plus y should be less than or equal to half. Okay, so let me explain this. So it is simply like this. So x and y belonging to 0 to 1, and simply the y also in between the 0 to 1. So if it is asking the x plus y is less than half, so let me here figure it out. So simply they are saying that ki x also belonging in between 0 to 1. It's a uniform distribution, and y is also simply in between 0 to 1. Okay. So when you add it up, x plus y, let's add it. So it will become in between 0 to 1 only. And x plus y simply will become 0 to 2 here, because it's a magnitude here is 1, here is also 1. Okay. So it is asking x plus y less than or equal to half. Okay, where the points is will be half. So this is a zero point 0.5, and here also it will be zero point 0.5. Okay, some basically it will be less than zero point 0.5. Okay, so draw it line. Okay, but let me see 0.50 0 0.5. Okay, so here in this region it will be basically zero point 0.5. Okay, so when you calculate the probability, because this will be the region, okay, where the sum will be less than zero point 0.5. Okay, so what will be the probability? Probability will be simply this area, where half multiplied by zero point 0.5 multiplied by zero point 0.5, and overall area, because it's x plus y term, so it will be simply 1 multiplied by 2. Okay, try to find out what will be the value. 1 by 4 multiplied by 1 by 4. Okay, it will be 1 by 16 basically. Okay, so the correct answer here, it's not correct. All options are not correct. So it will be simply not 1 by 8. It will be 1 by 16. Okay. Let's move forward. Try to solve this problem. Okay, let me give the solution for this. It is saying x is uniform distribution in between 0 to 1. So you have to compute E of x square. So E of x square basic formula is 0 to 1 x square fx. So let's see that. So E of x square is basically 0 to 1 x square fx dx. Here it could be any value, but we are the uniform. Here we are talking about the uniform distribution in between 0 to 1. So simply it will become start from 0 to 1, and this 0 to 1 x square, this is 1 in between 0 to 1 dx. So it will be 0 to 1 simply x square dx. Integrate it, it will become x cube by 3. In between 0 to 1 it become 1 by 3. Okay, so correct answer will be option A. You just have to remember the formula here, that ex square is equal to 0 to 1 x square fx dx. And when you say that uniform distribution is there in between 0 to 1, so simply it will be a value is 1, so 0 to 1 x square multiplied by 1 dx. Integrate it in between 0 to 1 x square dx, so it become x cube by 3. So 0 to 1 it is 1 by 3. Okay, the correct answer is 1 by 3. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. It is saying that a bag which contains the four white ball is four, black box black balls number six. So two bags are identical. One bag is chosen at random. Okay, so then two balls are drawn. Probability that ki both are white. Okay, so here it is not saying that ki whether it is drawn and then placed again. So let's compute it. Okay, so when you see for picking up of what is asking, they both are white. Okay, so finding out the what is probability of picking up the 4C2 and what is the overall 10C2. Okay, because the equal probability is there to draw the balls from the any of the bags. So it is basically 4C2 divided by 10C2. It is 4 by 2 multiplied by 3 by 1, 10 by 2 multiplied by 9 by 1. Okay, this is 5, so it become 45, and this will become 6. Further simplify, 2 by 15. Okay, so correct option will come out to be A. So this is simple. You have to draw two balls randomly and then place it kind of, and then drawing from the overall backs, that is 10C2. So probability is 2 by 15. Correct answer. Let's move forward. Try to solve this problem. Okay, let me give the solution for this. It is saying that you are having a uniform distribution of x1, x2 in between 0 to 1. Simply, it is saying maximum of x1, x2 is less than zero point 0.5, zero point 0.8 basically. So when you see that, it is basically x1 is also a uniform distribution and x2. So x1, sorry, this is 0, this is 1, this is 1, this is, suppose this is x1 basically, and this is also x2, here 0 to 1 and simply 1 here. So max of x comma x2 is less than zero point 0.8. Okay, when you see here, let me sort it like this. Okay, so when you say x1 is less than zero point 0.5 and x2 is less than zero point 0.5, that is basically the mean of maximum x1 less than zero point 0.5. Okay, so simply for stating the 2 points here also the area will be zero point 0.8. There the probability is zero point 0.8 because it's a zero point 0.8 comma the y-axis is 1. So the area will be zero point 0.8. Simply the here also zero point 0.8. So probability of maximum will be 0.64. Why? Because if you see here, this is not less than zero point 0.8. So this area x1 should be also less than zero point 0.8. Here also it is also less than zero point 0.8. Okay, not like this. Okay, let me remove this. Let me remove this also. Okay, let me explain. So it is what it is saying, this is x1 basically. So here it is 0 to 1, so it is 1 uniform distribution. So it is saying simply go till to the zero point 0.8. So this is the area. For x2 also you need the same area, that is zero point 0.8 only. This is 1. So this is the area basically. So you simplify when you say that area is x1, x2. They are independent events, so you can multiply it. Okay. So this is zero point 0.8, zero point 0.8, and overall your area when you say this is 1 cross 1 only. So this is 0.64. Okay. The correct option is A. Let's move forward. Try to solve this problem. Okay, let me give the solution for this. It is saying that for random variable x and y, which identity actually holds. When you say here the correlation of x and y, so cube proof is that it is derived like this. Okay, when you have this and this value similarly, where when the tau plus x is x measurable, so it is simply this and ex multiplied by ey. So this is simply the means the expectation of xy minus expectation of x expectation y, which is the convolution of x and y. Okay, so simply it is option B is that. Okay, let's move forward. Try to solve this problem. Okay, let me give the solution for this problem. So it is simply saying x and y is the exponential of 1, defining u is equal to x plus y and v is x divided by x plus y. It is asking what is the support of u and v. Okay, so this is simply u is equal to x plus y, v is equal to x plus y. When you solve for the x and y, so v is simply x divided by x plus y, that is u. So x will become uv, and put here in this equation y is equal to u minus x. So this is simply u minus uv. So you take u common, it will become 1 minus v. So and also u is greater than u is equal to x plus y. So since the x plus x comma y is greater or equal to 0, so u is equal to x plus y. Okay, so simply it is also greater than 0, and also v, which is greater or equal to 0, is equal to x divided by x plus y, simply less than or equal to 1. Okay, so for the density, taking u greater than 0 and v is in between 0 to 1. So when you find check also with the Jacobian, it will come out to be u. So the correct option is u is greater than 0 and v is in between 0 to 1. Okay, correct option is option B. Let's move forward, try to solve this problem. You have to just find out the Jacobian, which is determinant of del of xy, del uv. Find out the Jacobian of this. Okay, let me give the solution for this. When you say that ki x y u is equal to x plus y, v is equal to x divided by x plus y is there, and you have to find out what is the Jacobian is there. Okay, give me 1 minute. So it is simply u is equal to x plus y and v is equal to x divided by x plus y. Jacobian is Jacobian of determinant of del of x comma y divided by del of u comma v. Okay, what it will be equal to? So simply when you say, uh, let's find it out. U is equal to x plus y, x divided by u, x is equal to uv. Okay, what is the value of y? Y is simply equal to u minus uv. Okay, if I just find out the Jacobian del xy comma del uv, so it will in the matrix format. When you see, this is del x by del u, del x by del v, del x sorry, del u, and then del x by del v, and del y by del u, and del y by del v. Okay, del x by del u, it's simply v. Del u by y by del u is simply 1 minus v. Del x by del v is simply u. Del y by del v is minus u. Solve it. You will get minus vu minus of u 1 minus v. Simplify it, minus vu minus u plus vu. This will get cancelled out, and when you take the mod of that, and it will be simply equal to u only. Okay, so the correct option is option B. Okay, in this problem you just need the know that how to find out the this partial differentiation, then basically the Jacobian, and then apply the mod, and but just you have to convert in the xy format, so that will be easy to differentiate, do the partial differentiation, so it will be easy. Okay, let's move forward, try to solve this problem, a similar problem, but different kind of style it is been written. Okay, let me give you the solution for this. So in this problem, the similar way that u is given into x plus y format and w is given x minus y. So when you add 2, you will get 2x is equal to u plus w, or you can say x is equal to u plus w by 2. Similar fashion, when you subtract it, you will get 2y is equal to u minus w, and y is equal to u minus w by 2. Okay. Finding out that same Jacobian, that del xy divided by del uw is equal to the matrix del x by del u, del x by del w, del y by del u, del y by del w. Find it out. Del x by del u, it is simply zero point 0.5. Simply when you del y by del u, it is zero point 0.5. Del x by del w, simply zero point 0.5, and then y by del w minus zero point 0.5. Okay, find it out. It is 0.25 minus 0.25 minus 0.25. When you add, it will minus zero point 0.5. When you take the mod of that, it will become half, that is zero point 0.5. Option B is actually correct. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this problem. So here it is saying if the expectation of x is less than infinity, what would be concluded with x probability of mod of x is greater than x as x tends to infinity. So here the simple proof is that, because this is the correct answer, option C. Proof is that let fx will be probability of mod of x greater than x. So f is non-increasing, and when you say that it's a integral 0 to infinity fx dx, that is just a expectation of x is less than infinity, that is tail mean identity. But let's fix it some epsilon greater than 0, so choosing m, so that the is and from m to infinity, that is ft dt is less than epsilon possible, since the integral is finite. So for x greater than 2m, so f is non-increasing, so t belonging to x by 2 to x, so ft will be greater equal to x. So similarly, with this, you can say that x by 2 fx is less or equal to x by 2 to x ft dt, and m to infinity ft dt less than epsilon. So therefore x fx is less than 2 epsilon, and for all x is greater than 2m, implying that x p of mod of x greater than x tends to infinity. So option C is actually correct. Okay, it goes to 0. Let's move forward and try to solve the other problem. Try to solve this. Okay, let me give the solution for this. So it is saying that for the integral of x, which identify links the tail to the mean for x greater than equal to 0. So when you see this is simple. The layer cake only was there to define it. So this is simply when you take for any omega that is 0 to 1 and is a 1 for x omega is greater or equal to x dx. So when you integrate it and swap the integral and expectation, so simply take the infinite expectation integral inside the expectation, and after that take integral outside of the expectation. That is simply will become 0 to infinity probability of x zeta equal to x dx. Okay, since we the difference between the p x zeta equal to x and p x greater than x occur only at the countable many points, the jump points of the CDF. You say that key exponential of x is 0 to infinity probability of x greater than x dx. Okay, so this is other options are actually not correct. So the correct option is option A basically. Let's move forward. Try to solve this problem. Okay, let me give the solution for this. So it is saying for an integral random variable x which identifies tail sum Levesque formula for exponential of x. So simply it is why the theorem itself with option B is actually matches. So this is the actual formula that theorem basically expectation of x is 0 to infinity, probability of x greater than x dx minus 0 to infinity, probability of x greater than minus x dx. Okay, so the option B is correct. Let's move forward to the last problem of the today's session. So try to solve this problem. You have to find out the correlation of rho x comma y. Okay, y is a straight line passing through with a gradient of a and a slope basically where it is touching the y axis. This is b basically. So this is and this is a. Okay, you have to find out the a is greater than 0. So you have to find out rho of x comma y. That is coefficient of correlation will be equal to. Let me give the solution for this. So this is last problem. So the row xy is the convolution of xy divided by sigma x sigma y. So sigma x is basically the variance of x and sigma y is the variance of y. When you find out the covariance of x and y is simply x plus b. Put the value there. A of convolution of xx plus convolution of x comma b, it will become a times of variance of x. Okay, so simply what is the variance of y? Variance of y is variance of ax plus b. Keep the value, and here also constant variance will be 0, so a square variance of x, so sigma y is equal to mod of a sigma of x. Put the value here because a is the variance of x multiplied because from here, and then put in the value, that is a variance of x is simply because you have find it out the here a times of variance of x. So here also a times of sigma x, that is simply equal. So sigma x multiplied by a times of sigma x. So a sigma x square divided by a sigma x square will be equal to 1. Okay. So the option D is actually correct. Okay. Let's move forward. So this is the last session, last problem of the this tutorial session. So I have kept the multiple problems here also, and previously also the few problems were there. So you just have to brush up this all problem, that will help you to solve the assignments also and also for the exam. Okay, that's all for the tutorial 7. Today's session. Have a good day.